In this video, we are going to review physics concepts such as position, velocity, time, through a simple problem where a car is moving in a straight line and its position at various times is given by this table. We are asked to find displacement from time t equals 0 to time t equals 8, the average velocity from time t equals 0 to t equals 8, and then when is the car moving, stopped, and changing speed. So, number one, displacement. Displacement is given to us by final position minus initial position. So what is the final position when we're looking at time t equals 0 to t equals 8? Well, that's 14. And in this problem, the units are seconds and meters. Seconds for time, meters for position. So final position, 14. Initial position, time t equals 0, 0. 14 minus 0 leaves us with 14 meters as the displacement. And now what I want to add there, though, is what if the problem said, what is the displacement from time t equals 2 to t equals 8? Well, our final position would be 14. But if it was t equals 2 to t equals 8, the initial position would actually have been 8, because we would see that at time t equals 2, its position is 8. In which case, we would then get 14 minus 8, and the displacement would be 6. But for this problem, where it is asking us displacement from t equals 0 to t equals 8, we get 14 minus 0, 14. Next up, we are going to have to find the average velocity from time t equals 0 to t equals 8. Velocity we can find by using displacement divided by time. We calculated displacement to be 14 meters in the first part of this problem, and then the time changes by 8 seconds, going from time t equals 0 to t equals 8. 14 divided by 8 is 1.75 meters per second. And then the final question is, when is the car moving, stopped, changing speed? Well, let's look at each of these intervals of time. From time t equals 0 to t equals 2, the position changes. So the car is moving. From time t equals 2 to t equals 5, position also changes. But then from time t equals 5 to t equals 8, the position does not change. So the car is stopped. And that actually is the answer for this. When is the car stopped? The car is stopped between time t equals 5 and t equals 8, because you can see here the position is not changing. Now, what about when is it moving? Well, remember, it was moving from 0 to 2 and 2 to 5, but then from 5 to 8 it was stopped. So from time t equals 0 to time t equals 5, the car was moving. And now, when is it changing speed? Well, let's look at the actual intervals that we see here, t equals 0 to t equals 2, and t equals 2 to t equals 5. From t equals 0 to t equals 2, the change in position was 8 meters, and then that was over a period of 2 seconds, which means our velocity was 4 meters per second. But then from time t equals 2 to t equals 5, our change in position was 6 meters. 14 minus 8 is 6. And that is over a period of 5 minus 2 seconds, 3 seconds. 6 meters over 3 seconds, 2 meters per second. So what you can see is that the velocity decreases from 4 meters per second to 2 meters per second. So at time t equals 2, the speed changed. But then also we had a speed of 2 meters per second. The car was moving at 2 meters per second from time t equals 2 to t equals 5. But then remember, from t equals 5 to t equals 8, it stopped moving. So it went from 2 meters per second to 0 meters per second here, which means that also at t equals 5, the speed changed.